In this video, we'll practice identifying the function family of a graph, equation, or word problem, and we'll practice identifying which function family that one of those things belongs to. We will also practice identifying the domain and range of a graph. So for each of these graphs, what we're going to do is we're going to look at the shape of the graph, and we're going to determine which family function our graph belongs to. Now remember, the family functions that we know are the constant, the linear graph, the absolute value, and the quadratic. So for each one of these, we're going to have to write down, I'm going to have to split up that word there. For each one of these, we're going to have to write down which family it belongs to, so one of those four, and then we're going to have to determine what that graph's domain and range are. So it will be helpful to have your notes out for this particular lesson because you're going to need to look at those parent function graphs and determine which family function these graphs belong to. So if I focus here on number 1, what I notice about this particular graph is it's shaped like a V. And if I look at my parent function graphs, what I notice is that there is a parent function that's shaped like a V, the absolute value function. So because this has a similar shape, this is a child graph of the absolute value function, and this particular graph belongs to the absolute value family. So that similar shape tells you that it is an absolute value graph. Now from here, what we need to do is we also need to determine domain and range. So what I notice here is that this graph continues on forever. It keeps going off the page. It's going forever left and right. And because of that, all of the x values that I'm using to create that graph in red are all of the x values that exist. So my domain for this graph is all real numbers. Now from here, my range is a little bit different. Remember, range, I'm finding all of the y values that I need to make points on my graph. Well, if I look here, I notice that there's a low point right here, right at -3. And truly, I don't need any of these y values below -3, but I need all of the y values above it. What that's telling me is that all of the y values that I need to make that graph in red are greater than or equal to -3. Now from here, if I look at the next graph, what I notice is that this is a diagonal line going forever from left to right. So when I'm looking at which function family this belongs to, because it's a diagonal line, just like the linear parent function, this particular graph belongs to the linear family because it's a line, just like the linear parent function. Now from here, what I notice is that this graph is going forever to the left and right and forever up and down. And because of that, both of its domain and its range are all real numbers because we need all numbers from the left to the right and all numbers up and down to make points on that graph. Now lastly, if we take a look at graph number 3, what we notice is that this graph, even though it's upside down, has a U shape. It's not quite a V, so it's not like the absolute value graph, but we notice that it's a U. And if you look at the 4 parent graphs, you look at the constant, the linear, the absolute value, and the quadratic, what you notice is that this U shape appears in the quadratic family. So this third example is a part of the quadratic family. So this is the part of the quadratic family because it's got that same U shape. Now the last thing I need to identify are the domain and range, and I can see that this graph is continuing off the page, going forever to the left and forever to the right. So because of that, all of the x values I need are all real numbers. And then what I also notice here is that I have a high point on my graph. And the highest point that I reach is y is equal to 5. I don't need any of these points. I'm going to use a highlighter quick. I don't need any of these points that are up here to create my graph. I only need the points below. So the only y values that I need to create this graph are 5 or less. So notice I'm using all of these y values to create various points on this particular graph. So we're going to continue with that same objective on this page. So here we need to find the domain and range of each graph as well as identify its family. Well, number 4, I notice that it's a U shape. And to me, because it's a U shape, I notice that it matches the quadratic image. So this is the part of the quadratic family. I then notice the graph is going forever to the left and forever to the right, which tells me it has a domain of all real numbers. And then I notice that my range hits a low point here at -3. So because it's hitting that low point there at -3, we have a range of all of the y values we need to make points on this graph start at -3 and go up. So y is greater than or equal to -3. Then if we look at the next graph, number 5, what I notice is that this one is shaped like a V, just like the absolute value graph. So here, this is a part of the absolute value function family. So now that we've determined which family this belongs to, we're going to take a look at domain and range. And so here we notice our graph is going forever to the left and forever to the right. So we have a domain of all real numbers. And then our range hits a high point at -4, and then we use all of the y values that are less than -4 to create various points on this graph. So we have y is less than or equal to -4. Then our last one here is number 6. When I look at this one, I notice that this one is just a horizontal line here at -2. And that horizontal line looks just like the constant family. So this is a part of the constant family function. It has a domain because it's going forever to the left and right of all real numbers. And then the range, if we look carefully, the only y value that I'm using to create points on this graph is right here at y equals -2. So we have a range of y is equal to -2. So now what we're going to do is we're going to mix this up a little bit, and we're going to identify which family each of the functions below belongs to. So we're going to use some context clues, and we're going to look at the different types of equations and see which one it looks the most similar to. So just to remind you, we have the constant family, the linear family, the absolute value family, and the quadratic family. So if we take a look here at number 1, what I notice in number 1 is I have my function, it's called f, and the equation part over here says 3x squared plus 4. So what I'm looking for in this equation is I'm looking for some context clues that look like one of the equations for the parent functions. And what I notice here in question number 1 is that this x value has a squared. And if I look at all 4 of these function families and their function equations, what I notice is that the quadratic function, that one also has an x squared. So when you see an equation with an x squared in it, and the x squared, the squared is the highest power that you can see, you can automatically assume that this is a part of the quadratic family. Now if you look on here at these 6 equations, look and see if you can find another squared, because anything with the squared as the highest power is going to be a part of the quadratic family. And if I look through at number 2, number 3, number 4, number 5, and number 6, what I notice is that number 6 also has a squared. And what this squared, being around an x, is telling you is that this one is also a part of the quadratic family. So when we're looking at the equations, we're looking for those equation clues that hint to us which family these belong to. Now from here, we're going to look at question number 2. And what I notice here is that this one has those vertical bars like the absolute value symbol. And so because of those vertical bars, because of that absolute value symbol being in the problem, this one is automatically a part of the absolute value function family. And if I look through at my remaining equations, what I notice is that number 5 also has these same bars. So I can assume that this one is also a part of the absolute value function family because it has that same big function key to it. It has that absolute value contained in the problem. Now let's take a look at number 3. This one, what I notice is it doesn't have any squareds and it doesn't have any absolute value. So it knocks out these two completely. And we're down to constant and linear. And when I look at the parent graphs for constant and linear, what I notice is that the constant function does not contain an x value, but the linear function does contain a simple x value. So question number 3, because there's no squared and there's no absolute value, and it still contains an x, is a linear graph. And then finally, if we take a look at question number 4, what you'll notice in this one is that this particular function does not contain an x value on the right-hand side of the equation. It's just a number, which is very similar to the constant equation. And as a result, number 4 is a part of the constant family. And last but not least, we're going to take a look at an application. So here it says the table shows the height of a dirt bike x seconds after jumping off of a ramp. What type of function can you use to model the data? And then estimate the height after 1.75 seconds. So what I'm going to do here is I'm going to create a little sketch. So I notice that time is going up by about half a second, so I'm going to do the same thing here. So I have half a second, 1, 1.5, and 2. And then I'm going to go up by 4s here because I can notice a pattern of 4s. So I have 4, 8, 12, 16, 20, 24. And then I'm going to just draw a little sketch. So 0, we're at 8. 0.5, we're at 20. 1, we're at 24. 1.5, we're at 20. And 2, we're back at 8. So I can see this sketch here. So the first thing says, what type of function can you use to model the data? Well, I have those 4, constant, linear, absolute value, and quadratic. And what I notice here is that this looks to me like it's a U. And the graph with a U shape is the quadratic function family. So just by drawing out a sketch, I can see that this is a part of the quadratic family. Well, I don't have an exact equation for it, and I don't have all of the points. I can see that from the few points that I've been able to plot. Now, the last part says estimate the height at 1.75 seconds. And while this might seem difficult because I can't actually see the point over here, what I can do is I can go over to my graph and estimate, okay, here's 1.75. Let's go up to about here. That's where I'm hitting the graph, and if I go over, it's hitting a little bit less than 16. So I'm going to make an educated guess, just based on my sketch, that the height at 1.75 seconds is about 15 feet. Now, it might not be exact, but it's a good estimate based on the model that I sketched over on the right. So we can use just a quick sketch to help us not only determine the type of function we have, but also to make some predictions using the function data that we have access to.